Here's Canada,
I don't think Canada's that
and
far.
here's the United States. What type of lines are they?
Well,
There's
I
a
know
really
more about
bad
that
line.
because-
What type of lines are
He's
those?
just a big old wall.
Parallel.
Yeah.
Never touching.
Good
What do we
line,
call
it's
those?
just gonna be
Well,
Canada.
they are both horizontal, that's true.
Parallel.
But the most important thing is they're parallel. Now, I got a question. What's the slope of that line? 0. What's the slope of this line? Huh. All right.
Remember the game, go with Canada.
What type of lines are those?
Positive.
Still parallel. I mean, they're kind of crooked parallel, but they're parallel. And what's the slope of the lines?
Up to over 1.
Well, I actually went up 1, 2, 3 over 1. Oops, over 1. And I went up 1, 2, 3 over 1. What do you notice about parallel lines then?
They have the same
They have the same what?
everything.
Slope. Not everything. That's important. They have the same slope. Do they have the same y-intercept? This is a negative one, this is a positive one, they're not the same y-intercept. This would be at Canada and this is at the United States, not the same y-intercept. Okay, so we don't have the same y-intercept, but we do have the same what? Slope. And you want to write that in your notes. So please write that in your notes, take out your green books. And we're on 4.3.
Or 2.
I would put these notes on page,
7.
because you're going to be doing the extra practice, page 102.
Are we skipping 4.2?
Yeah, we're skipping 4.2.
Okay.
So, because I don't care about point slope, it doesn't matter.
Okay.
All right, but in 4.3 on page 102, right, parallel lines have the exact same what? Slope. So I got a question.
No.
If I say the slope of one line is negative a half, and the slope of another line is positive a half, are those the same slope? They're both a half.
The one goes down.
One goes down and one goes what? Up. Can a line that goes down and a line that goes up be parallel?
No.
No way. Okay? That's not going to happen. So these are not parallel. They have to be exactly what?
The same.
Exactly the same, meaning they both have to be positive and the same value. They both have to be negative and the same value. If they're going to be what? What
Parallel.
type of lines are we talking about? Parallel. Everybody got it? Okay, that's parallel lines. Okay, now let's talk about some other type of lines. Oh, by the way, what's the solution of parallel lines?
Y equals 0. What equals X? No solution. I've trust myself.
No solution. The interesting thing is when you have two lines that cross, that point that they cross is the what? This is the solution. That point is the solution. And we'll get there in just a little bit. We're going to be doing systems of linear equations where we have more than one line being graphed and we find the solution, we find the point they cross. Okay, now, let's graph this. Well, let's graph this. Real simple. What type of line is this? What type of line is this?
Vertical.
Vertical. What type of line is this?
Horizontal.
How do they meet? I mean, they obviously cross, but what's special about this type of relationship? They meet what?
They come to a point.
They meet at a point, that's for sure. Like I said, this one meets at a point. Does this one meet at a point? Sure. Does this one meet at a point? Sure. All these meet at points. So meeting at a point is good. It means it has a solution. But there's a special way these are meeting compared to those two I just drew. They meet at a right angle or a 90-degree angle. When lines meet at a right angle, what do we call that?
Perpendicular.
perpendicular, and you wanna write this in your notes. So perpendicular lines meet at a right angle. Now, just like parallel lines had something special about their slope, these have something special about their slope. What's the slope of this one, of the horizontal line?
0.
0 over a what? Over some number, right? If it's up at Canada, then it's 0 over Canada. If it's down in the United States, it's 0 over the United States. But it's always 0 over something. What about these vertical lines?
No solution.
It's actually undefined, but really that means that it's some number, right and left, over
0.
0. Okay? And that means, and that's because it's going to be a number, the y values are changing all the way along here. See how the y's can be anything? Remember, it's the y's over the what? X's. But the change in x is 0. There is no change in x. The x is the same all the way along there. So therefore, the denominator is 0. Notice the numerator was 0, and now the denominator is 0. Just keep that in mind for a second. Okay? All right. Let's think about this one. What's the slope of this line I just drew?
Negative 2.
Is it positive 2 over 1? Is it negative 2 over 1? Is it positive 1 over 2? Or is it negative 1 over 2? Is it positive or negative? That's the first thing I want you to just understand.
Negative.
How do we know it's negative? It goes down to the right. Everybody got that part? We know it's negative for sure. And then is it 2 over 1 or is it 1 over 2? Yeah, you got to think, how far down did I go? I went down what? 1. So I went down 1. And I went right, how many?
2.
So that 2 is positive, the down is the negative. That's why it's negative what? 1 over what? 2. Everybody agree with that? Okay? Now the y-intercept is obviously what? 4. So the equation, we did this yesterday, y equals negative a half x plus what?
4.
4. That's the equation of that line. Pretty easy. Okay, let's do this one. What's the slope of that line? It's positive, very good. Okay, how do we know it's positive? It goes up to the right. Everybody understand that? The reason it's positive. Okay, Griffin, what's the slope of that line? How far up did I go before I went over 1? Think about starting here. How many did I go up? 2 and over what? 1. Notice it's up 2, so it's positive 2. And then it's to the right 1, so it's positive 1 to the right. It's 2 over 1. So y equals 2 over 1 x. And then what's the y-intercept?
Negative 2.
Minus 2. How do those lines meet? Ah, they meet at 90 degrees also. Say, huh.
Huh.
Good, huh? Okay, now let's try this one. We're going to start up here. Where am I starting at? Can you count? Where am I starting at if I'm starting up here? How many up did I go, Danny?
Where's your line at?
Right here. I don't have a line yet. I just have this point. But where did I start at? Where am I? How high up am I?
9?
9. I'm at 9. Is 9 the y-intercept or the slope?
Slope.
No.
Intercept.
9 is the y-intercept. It's where I'm crossing the y-axis. I got a plus 9 on this equation. Okay, I'm going to do this. I'm going to go down 2 and left 1, and down 2 and left 1. Okay, if I'm going down 2 and left 1, wait, let me think here. Oh, wait.
Oh.
Yeah, if I'm going down 2 and left 1, what's my slope?
-2 over -1.
Ah, think about that. I went down 2, that's -2, but I went left 1, that's -1. What's -2 over -1 if I do my signs there? What's a negative over negative? It's actually a positive what? 2 over 1x. Hey, that's going up. Should it be positive? Yeah, it should be positive. And it is, even though I went down 2 and left 1. A negative over negative is a what? Positive. So we're good. Is that perpendicular also? Yeah. Huh. What's the relationship between the slopes of perpendicular lines? So parallel lines are exactly what? The same, but perpendicular lines. Look at what we have written here. Tell me what you think the relationship is between perpendicular lines. They'll meet at a right angle, but how do you describe the relationship between their slopes? What do you got, Logan? They're flipped. What do we call that in math when we flip a fraction? What do we
Inverse.
call that? Starts with an R. Reciprocal. Very good. Yeah. So though they will be reciprocals, they'll be flipped. And then what else? One's positive and the other one's what? Negative. So we call that opposite values. So we have opposite reciprocal slopes. That's what you want to write in your notes. Perpendicular lines, write this in your notes, have opposite, meaning opposite signs, reciprocal, flipped fractions, slopes. Opposite reciprocal slopes. Okay? All right. I'm going to start with an equation. Y equals 2/3 x minus 5. Yes? Yeah. All right. So let's start with this equation, Canyon. I want this equation, I want to write another equation that's perpendicular and has a y-intercept of 2. Okay, Canyon? I want to have another equation that will be perpendicular when I graph it to this equation and have a y-intercept of 2. What do you think the other equation is going to be?
Y equals 2/3,
Is it going to be 2/3?
not 3/2.
If it's 2/3, it'll be not perpendicular, but what? Parallel. Did I ask for a parallel line or a perpendicular line?
Perpendicular.
I asked for a perpendicular line.
So it'd be 3/2.
So is it 3/2? He's close.
Negative.
It's got to be what?
Negative.
Negative. Think about perpendicular lines. If one's going up, the other one has to go what?
Down.
Down. So this has to be negative. And we had to flip it, which is good. X, and then where did I want it to pass through? Where did I say it should pass the y-axis at? At 2.
So do
So just put plus what?
2.
2. Let's graph these and see if I'm right. Okay? Let's graph the top line. So Brian, where would I start on that top line? Where am I going to start my graph?
Y.
The y-intercept. What is the y-intercept? What's the y-intercept in this line?
2/3.
Nope.
-5.
-5. So I start on the y-axis. Don't start on the x. That's where kids mess up. Start on the y-axis at what? -5. Okay. Griffin, from -5, where should I go? If I'm graphing this top line.
Up to 3.
Right or left 3?
Right.
Right 3. It's all positive. Up 2, right 3. Can I go up 2 and right 3 again? Yeah. It's nice to have 3 points just because it's easier to line them up. I mean, you really only need 2, but they'll line up better and you'll have a better looking line, okay? That's a good looking line right there. Except for maybe this part of this. Kind of got skee-wombas. All right. Briley, where should I start the second equation at? or Braley? Is it Braley or Bradley?
It's
Braley, sorry. Where should I start this equation at? At 2 on the what? X or the Y? It's 2 on the Y. So that's the key, is where to start my graph. I'm going to start at 2 on the Y. From there, where should I go, Sally? I'm graphing this one right here. I'm starting at 2. Where should I go?
down 3
Yep.
and over 2.
Right or left?
Right.
Right.
Yeah, it's a positive 2 on the bottom. So I'm going down 3, positive 2. Can I keep doing that?
Yes.
Sure, I'm going to go down 3, over 2. I'm going to graph that. And what about those lines? They cross at a what? Right angle. So this is the way I show this on a graph, by the way. I make a little square in one of the angles, and that shows that they're what?
Right.
Perpendicular. Okay? That shows they're perpendicular. And I always want to show that because maybe I didn't draw it quite right, you know what I mean? Because I don't draw really well, honestly. But if I show that little box, it's perpendicular, which means they meet at a 90-degree angle. Okay? And that's good. All right. Is it hard to understand then when they're parallel versus perpendicular? Not too hard. Parallel, what about the slopes? Exactly the what? Same. How about the y-intercepts?
They can be different.
They're going to be different if they're parallel. If it's perpendicular, slopes are opposite reciprocals of each other. They could be perpendicular at the point of the y-axis. So their y-intercepts could be the same, but it doesn't have to be. Everybody got it? Okay, let's do a few. You can quit recording now.